So welcome everybody, and today we have Shijimol with us, who is a cloud solutions expert with 17 plus years of experience in IT industry with expertise in multi-cloud technologies and having a sound background in data center management and virtualization. She presently works with Google as infrastructure modernization specialist. So I would like to pass on this session to her to get started with today's topic, which is about cloud native application security. Please go ahead, Shishimon.
All right, thank you, Maitreyi. So I'll just start sharing my screen. Can you stop sharing so that I can take over?
Yes,
Yeah.
yes.
Are you guys able to see my screen?
Yes, your screen is visible.
For some reason, I am not able to see my screen. 1 second. But if it is visible, then we can go ahead. I'm going to move the slide. Okay. So, good morning, good evening, everybody, wherever you are joining from. So, my name is Shiji. Today's session is going to be about cloud native application security. So, I hope I am audible to everybody clearly and my screen is visible.
Yes,
Yep.
yes. All good.
All right, so let's get started. Thank you, Maitreyi and team, for the warm introduction. So this is going to be the agenda for the day. Okay, so I have a monitor here. So if I look this side, please be informed that, I'm looking at my monitor. Okay. So the agenda is going to be a welcome introduction, emerging threat landscape, application security in the cloud, again, supply chain security, that is DevSecOps, and data protection. And I will have some time for Q&A as well. Okay. So before we start, I'll just give a small intro. Thank you, Maitreyi, for introducing me. But just to give a little bit more context about, my body of work and my experience. So currently I'm an infra modernization specialist with Google Cloud. And I have experience of close to 17 years. I've worked across different segments, cloud computing, automation, DevOps, and I've worked across diverse industry verticals as well, leading technical pre-sales engagement, delivery engagement, cloud transformation programs. So I enjoy working with communities, mentoring, conducting talk sessions, blogging. Those are some of my areas of interest. Now let's get started with the session. So today's session is about cloud native security, right? How do you protect your applications in the cloud? Okay, because today we have a number of threats that are, emerging and different from what it used to be, say, 5 years or 10 years ago, right? Because we are seeing a lot of cloud adoption these days, and along with cloud comes modern threat vectors that we need to eliminate. Okay. So let us start with the problem statement. So what is the current threat landscape that we are looking at that we need to protect our cloud native applications from? So how are applications built today in the cloud? So when we talk about a cloud-based application or a cloud native application, right? Um, So there are different native technologies that we use, not just traditional machines in which you deploy the code, right? So you have containers, which in turn is a immutable infrastructure where everything is binded in the image that you use. Your functions as a service, you use APIs, right? And the norms of security are different when we compare a virtual machine to a container, okay? And the security is not just the code, it should be part of different aspects of an application in the cloud. Okay. So what we are looking at is a change in how the applications are being built and deployed. Okay. Now, along with this, new ways of building and deploying applications, so are the ways in which they are being attacked are evolving. Okay, so there are different kind of attacks that we see today. For example, we see DDoS attacks, overwhelming an application with a massive number of requests so that the application is not able to respond, right? Credential theft, you get a link, you input your credentials, that credentials are used to access your applications, steal your sensitive data, financial frauds, application frauds, your applications exposing APIs, and APIs can be accessed or misused by attackers, right? Infrastructure level attacks also happen, data the infrastructure level vulnerabilities. For example, your operating system is not patched. That vulnerability can be exploited by an attacker. So that is a little bit more traditional way of attacking, but that still exists along with other ways of access as well. Next, we can talk about unauthorized access. So that means somebody has access to admin credentials and they're using it to do exfiltration and move parallelly in the system, right? So that is also a common form of attack. That kind of attacks usually go undetected because you are having somebody's credentials who has an access to the environment and you're using that for illegal activity. Okay, so those are the different kind of attacks, and they all sometimes are wrapped in such a way that they look very genuine. For example, you might be seeing some widgets that look like, this is a great widget and you need to go and use it and all that, right? So you might get tempted to go and use it. But once you start using it, it gets exploited and, it will have some malicious code in it that gets injected in your application. That is where the attacks begins. Okay, so that means the application vectors are multiplying rapidly. Attack vectors are multiplying rapidly. Now let us look at some of the different cyber threats. I mentioned about cyber threats having evolved. Okay, so how have they evolved, right? So let's look at the first different set of cyber threats that we are talking about. Going to talk about in this session, how to prevent them. So just a disclaimer before I start, I have structured it in such a way that people who might be an experts in security or people who are just starting in security can also benefit from it. Okay, so that is how I structured the session. So if you need me to explain anything more, please feel free to stop me and raise your hand so that I can explain it a little bit better. And since currently I'm working in Google Clouds, the solutioning that I'm talking about will majorly, a lot of it will be evolved or revolved around Google Cloud. But these are common mitigation measures that will have equivalent features in other cloud as well. Okay, so I will mention them as we go. But just want to set the expectation here and set the tone for the session so that we are all clear on this. Okay. Okay, let's start with the different cyber threats that we are talking about. So we have ransomware. So what is a ransomware? So that means it involves malware. Okay, so these are malwares that encrypt an organization data. So you see attacks where attackers go access organization data and then say that, hey, if you want your data back, you need to pay me this much money, right? And unless you pay the money, you will not get the key to decrypt the data, right? That means the organization business comes to a standstill until you pay the attackers. Okay, that is ransom, right? This is like kidnapping somebody and then asking for a ransom, right? If you want to release that person, here your data is being kidnapped essentially, right? So you need to pay some money if you want to get back the data. Next is phishing. So these are like genuine looking emails that come from. I'm sure we all might have got emails from like some Nigerian prince who want to give you half his fortune, right? So those are the kind of phishing emails, right? That what is the intention? You can if you click on those links and it will take you to a page which looks very similar to a genuine say banking page, for example, right? You enter your data and then they will get your credentials and they will misuse it, right? So that is phishing attacks. Next is supply chain attack. So what is supply chain attack? That means there are several third-party suppliers that provide services to an organization, right? It is all the application may not be built by the organization. There'll be third-party solutions that you're using. This could be your cloud-based application, could be using some plugins, for example, right? Um, and you might be using some additional softwares, right? So there could be some vulnerabilities in those components that are being leveraged by that. Okay, so it becomes very, very difficult to detect. Okay, at some point in time, it becomes very difficult for you to detect what is going wrong. Okay, or where is this error coming from? Because it's not your code; it is part of some other code that you're using in your application, right? Insider threats. So this is a very nuanced form of attack, wherein employees or contractors, right, people who don't have with authorized access to organization data, they will use that access to intentionally or unintentionally cause harm to your environment. Okay, so that is the insider threat. Okay, so that means these threats can be difficult to detect and prevent. For example, you might be looking at the audit logs, you might be looking at the access logs, but you will not see anything over there. Why? Because this data or what you're looking at or the audit log is that of a genuine user. Okay, but you don't know if this person is accessing that data to create a harm. Okay, so it will be very difficult to detect and prevent unless you see some anomalies in terms of a specific data transfer to a location that shouldn't have, right? So unless you have that kind of a monitoring, it'll be very difficult for you to understand that this is actually an attack happening, because the users who are doing it are legitimate users. Okay? So zero-day exploit. So this is another interesting way of attack, wherein attackers identify the vulnerabilities much before the software vendors. So that means they know that your software has a vulnerability, they know that your application has a vulnerability, then they will try to exploit it before you even get an opportunity to patch it. Okay, so since this attack happens before a solution is present, it will be very difficult to mitigate it. There will be some kind of damage that happens. So that is zero-day exploits. Next is advanced persistent threats. So these are like long-term attacks, long-term very targeted attacks. So it happens most very slowly, but it happens over a longer period of time. Okay, so they gain access to organization system, data over extended period of time. Okay, so this requires a lot of skills. Usually it is an organized attack and is carried out by highly skilled cyber criminals. Okay, so these are some of the common kind of attacks that happens in the cloud. Okay, now let's look at the impact of these emerging threats on cloud native applications. So why are we talking about this threats? These threats are common, but from a cloud native application perspective, why should we have an awareness about this threat and have measures in place to mitigate them? Okay, the reason being, in cloud there's an increased vulnerability to increased vulnerability of supply chain attacks, because cloud native applications rely on third-party services. Okay, so when you are building applications in the cloud, many organizations do not build the entire application stack on their own. They might be depending on third-party vendors. They might be integrating that with a third-party service. For example, you have a solution and you are integrating that with a third-party voice over IP solution to provide enable voice calling, right? So that part of the software might be coming from a third-party vendor, but you're integrating that into your code and your code is interacting with that, right? So that is the possibility of a supply chain attack. Next is greater risk of data breaches. Okay, so cloud native applications are most often, they're designed to process large amounts of data. Now, cloud, what is the benefit of the cloud? Scalability, right? You can store petabyte scales of data. So we're not talking about say few GBs or TBs of data. We're talking about petabytes of data, right? So that means, if somebody gets access to that data, it is a gold mine of information for them, right? They can sell that data and, benefit out of the data, analyze the data, get some information and use that. So there are different ways of, leveraging that data that is available because of the sheer scale of the data. Next is detecting and mitigating threats. And often when it comes to cloud native applications, it's distributed across different clouds. The cloud native environments many customers adopting cloud are not limiting themselves to a single cloud. Most of the customers I talk to as a specialist, as a cloud specialist, will have their footprint in a couple of clouds. It's not just Google Cloud, right? So that means it becomes very difficult to manage such an environment. Okay, you may have security controls in place, but you may not be able to look into the effectiveness of that in all the different cloud environments, right? Next is new attack vectors. Okay, so again, when it comes to cloud native applications, there is a ocean of possibility there, right? There could be multiple platform as a service solutions. There could be multiple container solutions. There could be multiple functions as a service. So there are a lot of services available in the cloud. Why are customers moving to the cloud? Because of the different kind of solutions available. But that also means the kind of attacks that you could face is different from a traditional application where, say, your application database, middleware, everything is running on a single server, right? So here you're seeing different components. So even if your, say, for example, platform as a service part of the solution is safe, there could still be a vulnerability in the function that you're using, which could negatively impact the application. The threat actors could try to exploit that vulnerability to get into your data, right? So that is a possibility. Okay, it is not as simple as protecting a single monolithic application, right? Because of the sheer number of solutions that is being used. Next is risk of misconfiguration. Okay, so misconfiguration is a very, very underrated, I would say, reason for attacks. But trust me, that is something that attackers are looking at. Okay, for example, you deploy a solution. There are basic security guardrails that you're expected to implement. But most often, what I've seen is customers fail to look into that. It's just a matter of bringing the server or bringing the application online, and they're all happy. Okay, it's done. But there could be a very small vulnerability, very small misconfiguration in there that could open the door to an attack. For example, you could be opening a vulnerable port in your application, right? So that could lead to an entire downfall of your application. That is a very real possibility. Okay, so that is a misconfiguration. Somebody missed to apply a security control which could bring down your entire application. Now, if you look at the history of cyber attacks that is happening in the world, if you look at the recent some of the cyber attacks, this is testimony of how attackers are working, how attackers are organizing their attacks to look at this cloud native vulnerabilities, right? SolarWind attack happened in 2020, wherein it was, I'm sure most of you must have heard about it. It is a highly sophisticated cyber attack that is carried out against SolarWinds, right? So it is a leading IT management software, and what happened is they compromised the update mechanism. So that means they found a way into the softwares, how the software is being updated. And when the software got updated, they managed to distribute malicious software. So whenever you're using an application, you get a notification to update the software, you will go ahead and update it, right? So you won't suspect anything malicious behind updating an application, but that is what happened there. But they updated the application and that gave entry for the malicious software. Okay? Capital One attack. Okay, so again, another hyped attack that happened in 2019, where a hacker was able to gain access to customer information, right? So this information like credit score, social security numbers, very sensitive information, right? So once the data is accessed, then it was I mean, what can we do with the data, right? You have the addresses, credit scores, SSMs, and all. You can sell it to people who can use it for different malicious intents, right? So that happens, and what led to this attack? Again, if I can draw your attention back to the misconfiguration aspect, it was a misconfigured firewall. Somebody left a configuration, somebody missed a configuration, somebody didn't make didn't implement the security control, which led to an attack, which opened the door to this attack. Okay. JPS, again, a ransomware attack. That means, the data, somebody got hold of the data, and then, they had to shut down their operations, because data is definitely the lifeblood of any business. You don't have your data, means your business comes to a standstill, right? That is why ransomware attacks are very effective, because, companies, most of the time, companies pay the ransom quietly, and so that, they can bring their business back online. So the ransom that they need to pay will be probably, when they compare it with the business loss, they might find it better to pay the ransom and get access back to the data. But that's an unfortunate situation. Ideally, it should not happen, because you should have enough security controls in place to avoid such a situation. Now let's talk about application security in the cloud. We talked about the different type of attacks, how the attacks can happen, and now let's look at how you can secure your application. So what are the different ways of implementing application security? Okay. Whenever we talk about cloud, we always talk about a shared, responsibility model, right? I'm sure most must have seen this, diagram multiple times in terms of the shared responsibility model. But we are talking about it from a security context, okay? From the context of the security, when it comes to on-premise, IaaS, container as a service, platform as a service, software as a service. So when it comes to cloud, there are certain responsibilities of cloud service provider. There are certain responsibilities of customer. Okay. So the customer is supposed to, make sure that in an on-premise environment, the entire solution is protected, right? So from end to end, all the different tools for measuring compliance, such as IAM, network, infrastructure security, data security, encryption, supply chain security, all that has to be done by the customer, right? Now, when it comes to infrastructure service, wherein the cloud is providing the infrastructure, right? All the security controls has to be implemented from the OS level and upwards. Okay? However, the cloud solution or cloud service provider, we take care of other, the physical hardware security, right? Who has access to their data centers, how the access is controlled to their data centers, how the cloud assessments are done. So most of the cloud service provider will provide you reports for the different type of security audits for the environment, be it SOC 3 audit or any such kind of audits. You can get the audit reports, but be aware that it is for the cloud environment, not for your application. That is something you have to do. That is the shared responsibility model. So in container as a service, again, you have to do from starting from the middleware onwards, you have to take care. From platform as a service up to the runtime vulnerabilities, everything is managed by the service provider. But starting from the application, in ensuring access of the identity and access management, encryption, so all that has to be handled by customer. SaaS, it's again the data and configuration that has to be managed. Okay. Now, next is the different kind of solution, different kind of security requirements when it comes to different deployment models. For example, it could be a bare metal machine, it could be a traditional app machine, it could be modern app containers, or it could be serverless applications, right? So wherever it is, wherever there is an app code and its dependencies or an operating system that comes in the picture, you need to take care of a lot of aspects, right? You need to protect your applications of different kind of attacks, right? What are different kind of attacks? API attacks, DDoS attacks, client-side attacks, malware attacks, right? OWASP top 10 vulnerabilities, which talks about the different kind of, vulnerabilities like, SQL injection and all those kind of vulnerabilities, right? That could impact your application negatively. Credential theft. So those are the kind of application security, application security protection that we need to enable. Now, coming back to the difference between the traditional and the cloud deployments and how security differs. So this is how a traditional application will look like. There'll be multiple components in an application which are all tied together, right? It's a monolithic application. This is how a monolithic application will look like. Now, when it comes to microservices, we can see that the different components are being distributed distributed into different services. They are different microservices. They are no longer a single unit. Okay. Now, when you secure a traditional application, okay, um, you can see that when you secure a traditional application, you can see that um, it is just one interface here, right? One interface that you need to secure, because everything entry point to that application is through one interface. So that is just one area that you need to make secure. Okay. But when it comes to microservices, the things change slightly, because we saw earlier that, there are different kind of microservices. There are different microservices there. And each of these microservices will have an interface. Each of these microservices will be exposing, some of them might be exposing services to the internet, right? So, and there is a user repository from which these are being deployed. So there are different entry points for an attacker to an application when compared to a traditional application, where the entry point was typically a single interface. Now, I have broken down the application security considerations into like 4 main areas. Okay, so we will touch upon these 4 main areas today. So that is comprehensive threat protection, identity, that is zero trust security, data security, and DevSecOps, which is usually called as shift left, or secure CI/CD, and trusted as a code. So these are some of the terms that you will hear in a conversation about DevSecOps. And I will touch upon some of the solutions that you can use for each of these areas. For example, comprehensive threat detection, what you can use, zero trust security, what you can use, how can you ensure data security, right? So I'll touch upon some of the solutions for this. Some of them might be specific to Google Cloud, but when it comes to the cloud of your choice, you can always use equivalent solutions. But it's just we will discuss about the approach for, say, for example, threat protection. Okay. So how do you ensure threat protection? This is how a high-level solution will look like if you're implementing threat protection using Google Cloud. Okay. So we have Cloud Armor, which provides DDoS protection. So DDoS protection means protecting from distributed denial of service attacks. So that means these attacks are designed to overwhelm your web application, so that it becomes inaccessible to legitimate users. So that means your application can only handle, say, 10 requests. Attackers, what will they do? They will send 100 requests. So the application is not designed to handle 100. So that means the application will come down. It will become overwhelmed with all the requests. It will come down. Now, application attacks. So that means there might be some vulnerabilities in your application. You might be using an outdated library, which has a vulnerability, which the attacker can target and gain unauthorized access to your system. Next is content security policy violation. Okay, so for example, your application might be loading the sources from untrusted sources. Okay, ads, social media widgets, right? So if the data is being loaded from such untrusted environment, untrusted resources, that could lead to an attack. Botnet attack. So what is botnet attack? So it is carried out by a network of infected computers. Okay, so they're known as botnet. Okay, so it is controlled by a malicious actor, right? So there will be a organized attack using bots. Okay, so bots, again, the attacker first gain access to those computers and use those computers to attack an application. Okay, now with Google Cloud, different services that we use, we have Cloud Armor, which provides DDoS mitigation. So the DDoS traffic can be filtered out before it reaches your application. You can create different policies to identify and mitigate such attacks. There are different kind of known DDoS attacks that can be mitigated by the solution. Okay, so you need to have a must-have. That is a must-have when you design your solution, is to have a DDoS protection solution. Next is a web application firewall. Okay. Now, web application firewall can block wide range of web level attacks. There are different kind of attacks that can happen at layer 7 or at web level. That is SQL injection, cross-site scripting, file upload attacks, right? So those kind of attacks can be protected by a WAF. Then content security policy is something that you can implement. So that means, You can block resources from untrusted resources using content security policy. Now, botnet detection is something that you can do. You can identify traffic coming from botnets, okay, so that it can be protected before it reaches your environment. Now, we should also look that is this bot attack protection is provided by a service called reCAPTCHA interface, which I'll explain a little bit in detail. Okay. Now, we also in most of the solution, most of the applications expose APIs that should be used, that is accessed by other consumers, right? You have an application, somebody might be accessing your API to do something, interact with their application, ingest data into your application, right? um, but how do you trust your API usage? You are exposed to the API. How what if somebody uses that API to attack your environment, right? So using intelligent API defense solution, there's a service in Google Cloud is called APG. So there is an API abuse detection that you can use. There's an APG abuse feature. So if somebody tries to use the API in such a way that is not the intended way, let us say making too many requests, trying to access your data, so that can be detected by the service. Next, again, misconfiguration. The API is configured in such a way that it can be exploited, right? So that can be detected by an API defense mechanism. Vulnerabilities, again, it is similar to say attacks like a SQL injection vulnerability, cross-site scripting vulnerability. API might have a vulnerability that can be exploited by an attacker. So API defense mechanism can use that as can detect that. Now, reCAPTCHA is the board, technical solution that we use for preventing botnet attacks, because bots are not human, right? So not every person accessing your application could be human. Some of them could be bots. Okay, they might be trying to create some fraud accounts to commit some fake accounts to commit some frauds. They might be posting fake reviews. Um, they might have an data. They might have purchased a database of leaked accounts, passwords, and they are maybe trying it out on your system to see if they're legitimate, right? Um, so they will take data from one side and try it on other. Okay, so they are generally bad influence. So we don't want them on your environment, right? So that is where reCAPTCHA Enterprise is a solution that protects from such kind of attacks. So it protects from automated abuse. So bots are like automated attacks. It's not like somebody sitting and entering the data every time, right? So there is advanced machine learning mechanism in play here, so that can identify between real users and bots. So that means you can focus on managing your consumers rather than preventing those attacks. Okay. So this can help prevent fraud and also secure your web and mobile application. So and also protect from spam and abuse. For example, you might have seen reCAPTCHA prompts when you try to log in, right? So that is something that can protect you from bot attacks. Now, defense in depth. This is a security principle followed very closely by Google. So in this, again, this is something applicable for every cloud application, and not just Google. But what do you mean by defense in depth? That is based on identity, right? So we often talk about identities and security perimeter when it comes to cloud, right? So who has access? You can protect a lot of attacks by granting permission only to required people. So we often hear about the principle of least privilege. Then there is organization policies that you can implement, saying that what kind of configurations are allowed. For example, you can create a policy says that external IPs are not allowed. So that means you'll not be able to create a machine with an external IP. And you can apply policy across different environments using tags. There is policy intelligence service that can actually look at your environment, analyze your environment, and say that some policies are not strong. You need to strengthen them a little bit more. Okay? So you can manage policies using policy intelligence. So this is one very important statement. So implicit trust in any component, okay, in any single component of a complex interconnected system can create significant security. So you can say that, oh, you cannot say that this component of mine is safe. It is completely safe. You should never assume trust. You should never say that it is safe, right? You should always assume breach. So that is one mantra that we often hear when it comes to security. Assume breach. Okay, so assume that your application is vulnerable, and then you go from there, right? So that is where we talk about zero trust security models. This is again from a Google perspective, but again it's applicable in all cloud environments. See, when it comes to cloud compared to traditional environments, not just the network security that we are talking about. Okay, so it is about the perimeter has shifted from the network to individual users because people are connecting from anywhere. The applications in the cloud means accessible from anywhere in the world, right? And most often VPN is also not required. So how do we ensure that people who are accessing an application are legitimate users, are secure users? Okay. So in today's world where people are there are a lot of mobile users. Mobile, when I say mobile, is not people accessing applications from mobile, but rather people who are moving around in their job, right? Digital nomads, so people who are accessing the application from anywhere, right? So that is where you need a better security measures in place. So what are the core principles of implementing this? Okay, so no privileged networks. You cannot say that somebody is accessing something from a specific IP range, they are secure. No, that is not how we do it. Okay, that is not there should not be any privileged networks. Okay? Uh, Trusted identity and devices. Okay, so the security starts on the device. If you're accessing from a device, it is more. This is more from an organization perspective. Make sure that it is a trusted device that is accessing your application. Okay, so the access should be granted based on the identity of the device and the user. And sorry, next is resource access. Okay, so authentication, authorization, encryption, security, very important. Okay, so there should not be any slack done in any of this. Make sure that you're securing the application every step of the way. So digging a little bit more deeper into the zero trust approach, the zero trust security approach, uh, make sure that you know the user, you know the device. Okay, so who's accessing, from where are they accessing? There should be an inventory service. Okay, make sure that you are correlating this information. Who is accessing what device? Okay, so if there is a credential threat that is happening, and the person is accessing from an unauthorized device, so that could raise a flag, right? Access control engine. So there should be a identity and access management service, right? So dynamic trust level per device. So that could be based on the certificate on the device. So each device, managed or unmanaged, should be handled based on the access policies. Okay. Enable access on the target. Okay, so you can deploy application behind reverse proxies. Okay, and you can enable access policy enforcement. Okay, so that means you again, this is a context based access. You check the user context where the user is accessing from. Say for example, your target users, you're deploying an application where the target users should only be from US, right? But if you see a user accessing it from a different country, right, that could be an attack, right? So your system should be sensitive to detect that kind of access and deny the access, saying that this is not the context from which this application should be accessed. Okay? That is zero trust. Okay? Now, data protection. Now, data protection is again very important aspect of securing your application. So how can we ensure data protection? So there are different ways of doing it. Encryption is most important. You should manage your keys in a key management system. There should be a mechanism to manage your secrets. Okay, I'll explain what that is. You need to classify your sensitive and personally identified information data, PIA data, because in regulated environments, access to PIA should be highly monitored and controlled. Okay. Now, encryption. When it comes to encryption, so that means you are protecting the data by encrypting it. It's very simple and straightforward, right? So the data should be encrypted at rest and in transit. Sometimes data should be encrypted in use also. That is where you can use confidential computing. So in confidential computing, just to shed a little bit more light, it uses hardware-based trust execution environment. Okay, so there are specific hardware available for that. So make sure that even the data is isolated, where the data is being processed is isolated from the rest of the operating system. Okay, that means even if your operating system is compromised, the data in that trusted environment will not be impacted. That is the encryption of data in use. Okay. Now, again, additional data security mechanisms in the cloud that you can leverage for your applications include um, encryption address we already explained. Then key management. So what are you going to, so when you do encryption, you use data encryption, you encrypt the data using data encryption key, then you wrap that key using key encryption key for an additional layer of security. Okay. Now, key management, you how do you manage this key? So whatever key that you're using for encryption, that should also be secure, right? If somebody get access to that key, then your data is gone, right? So key management should be done in a secure way. So there are different key management services available. So for example, in Google, there is KMS, and then Azure, there is Key Vault. So there are different service providers offer different service for key management, but it is always recommended to use a key management service. Secrets management. For example, you have a password that you're going to use to access the database from the application. That is a secret, right? So those are cloud-based secrets. So those when your application is in the cloud. So there are solutions available to manage those secrets. Okay. Enable key rotation, prevent unauthorized access, versioning, all that, right? Data loss prevention. So that is again sensitive information. How people are accessing your sensitive information is done by the data loss prevention. So you can identify and protect your data such as credit card numbers, social security numbers, health records. So all that can be protected using data loss prevention mechanisms. For example, credit card numbers can be masked. You mask credit card number, and even if somebody gets access to your database, they will not be able to use the data because the data is masked. So you need to go through the data loss prevention mechanism or whatever mechanism you use to mask the data to unmask the data so that you can use it. Okay. Now, supply chain vulnerability or DevSecOps. Okay, so this is again securing the data from the very beginning. So that is when it is actually being written. Okay. Now, the advanced threat vectors say that um, the attack starts even before the apps become app. That is at the code. At the code base, attack starts in the code base. Okay. So that means you need to secure it at the source. You need to secure the source code. So that means securing the supply chain is neither well understood or well solved. Okay, because we feel that okay, I deploy the application and I will implement security measures. So this, what if the data, the attack has already crept into the code, okay, or injected some code or during the development phase, right? So that is where secure CI/CD pipeline. So that is the DevSecOps part of it, or secure CI/CD. You will hear it with different names. Okay. So secure CI/CD means you are securing it in the code base itself. Okay. So how does it happen? For example, if you're deploying a container, um, you make sure that um, you deployed you use a trusted image for the deployment process. Okay, so that means you use a secure based container image. Okay, now it can be scanned in the container registry. So when you deploy applications container, you save in the container registry. Okay, so you can check the image for any kind of vulnerabilities, and now you can sign that image using a submit 15K. That is a binary authorization. So during deployment, this key is checked, and if the key is not matching, that means somebody tampered with the image. The image what you are using is not not the one that is being signed by your key in your key management service, right? That means it's a tampered image and it will not be deployed. So these are different kind of at each step of the way you can implement these security mechanisms like trusted image and scan the image, ensure that you are signing it with a key, and then you are checking it later during deployment. So these are different ways of securing your CI/CD pipeline. So binary authorization, a little bit more double clicking into that. You can see that you sign in each stage of the CI/CD deployment, and you make sure that at each stage, build, test, scan, analysis, each stage you sign, okay, during the CI/CD pipeline, and you have binary authorization to make sure that the states are signed off. Okay. Now that means even if there is a single failed signature, that means that the image is not trusted and it's rejected. Okay. Um, and what is a common source of vulnerability is most often unpatched third-party software. Okay, so that means these software will not have attestation from a trusted CI/CD process. So in addition to signature-based verification, you can also use whitelisting. What does whitelisting means? You can mention that certain repository or certain path you should only use images from those paths or from those repositories. You can whitelist. You can do whitelisting also. Okay, so if it is not signed, if it is not whitelisted, it gets rejected. It will not go into your application at all. No, we'll conclude with some additional considerations while you are going into a cloud native deployment for security. So, we've discussed different ways of securing your application, how you can ensure data security, how you can ensure supply chain security. But, how do you ensure that, what are the other ways of ensuring security? We talked about zero trust security model, right? We can have a traditional network perimeter based security model, but that is no longer sufficient. We already discussed how you can implement security on a context aware, right? And you can also monitor your activities happening in your environment. So, you can see that there is any kind of events that should not be there. Okay, somebody is accessing from a different network. The data is moving in a unauthorized track. So all that should be monitored and logged. Okay, and then of course it goes without saying that security assessments must have. You should do it regularly. And then review the findings, and then based on the findings, you can further fine tune your security measures. You further fine tune your security guardrails, container and orchestration environment, for example, Kubernetes. Okay, so they have certain unique security requirements that might be different from how you are deploying it in a traditional virtual machine, for example. Okay, so we talked about container image scanning. We talked about signing, right? So those kind of mechanisms should be implemented. And you should also make sure that you're implementing least privilege access controls for container runtime, because containers, we know that share the operating system, right? So it shouldn't happen that somebody accesses the container and through that they access to the host system, and from there they get access to all the other containers, right? So make sure that there is a principle of least privilege implemented in the container runtime. You can also implement network segmentation. So to make sure that, even if somebody gets access to container hosting environment, they did not get access to the underlying infrastructure, and and disable any kind of lateral movement of threads. Okay. So I think that is pretty much what I had for the session. So open to questions now if you want to ask any questions, anything that you would like to share. Um, happy to take up any discussion points. Any questions? Okay. I don't see anything in the chat. So I think if we don't have any questions, then we can wind up the session.
Thank you for an amazing presentation.
There's there's one question. What is your favorite part of cloud security? Okay. There's no favorite part as such, which I would say, but again, what interests me the most is the concept of zero trust security, which is very interesting, which is completely different from what we look at it from a traditional perspective, because I come from traditional data center management, virtualization background. So there we are always focusing on the perimeter security. But when it comes to cloud, it's very interesting that we have a zero trust mechanism and zero trust approach that we can use. Okay. All right, so I think the questions, I don't see any more questions. So, so if you have any questions and if you would like to reach out to me on LinkedIn, I'll put my LinkedIn profile here. and happy to connect and have a discussion if you're interested. And thank you so much for being patient and joining me today in this session. And thank you so much for the team for organizing this session. Thank you, Maitreyi. And thanks everyone. So I'll just put my LinkedIn profile here so that you can ask your questions. Reach out to me later also if required. Yeah. Yeah, there's another question. I think is there any resources you would recommend for someone curious about cloud security? So there are multiple resources available in the internet. I would say that there is like an ocean of resources available out there. So you could start with, I would say, some simple courses in YouTube, which are like free to all. Or if you are more interested in a specific cloud-based security, so if you're working on Google Cloud and if you want to learn more about security, I would recommend some courses in Udemy that is completely focused on cloud security. And one way, one hack I would say to learn about cloud security or cloud security is to, for example, focus on a specific certification. I'm not I'm not saying that having a certification is the only thing that says that you are an expert. You could be an expert without a certification also. But when you prepare, when you want to learn something, that is something I follow personally. When you want to learn something and become an expert on a subject, you find a certification on that particular subject. You focus on some courses on that subject. You try to do something hands-on. That will help you learn. So that is my way of learning. So I hope you also find that helpful. So find some courses, find some specific certifications on security, go through some courses focused on that particular area. That way, I think you will learn better. And you should always try hands-on is another suggestion that I would have. Yeah.
Thank you for sharing your tips, Shijimol.
No worries. I put
So,
my
any other questions anybody has?
Yeah, I put my profile in the chat window. So if anybody would like to reach out to me personally as well, I'm happy to connect and discuss. Yeah.
Sure, that would be great for all of us. And please stay connected with our next events with Women Who Code, which is on 17th about book club. And the next one is on 27th April, which is about getting started with cloud. So you can learn more and register yourselves for our events on womenwhocode.com/cloud. And that's all from our end. And thank you everybody for joining today's session.